Good morning to one and all. Now today class was taking the problem class for final BSc Fifth Sem presented by Rajshekar A.S. Assistant Professor Department of Physics, Government First Grade College for Women's, Tumkur. Learning objectives to enable the students to develop the problem solving skills and session outcomes. Problem solving skill is developed for the students. Before going to solve the problems, now in the today class, to solve the problems of luminosity and brightness of the stars. What's a luminosity? Luminosity means how much of the energy radiated per unit area per unit time. What is L is equal to E by AT. Brightness is defined as the ratio between the luminosity and area. Luminosity of the star and surface area. The relation, what is the brightness? Brightness is defined as the ratio between the luminosity of the star and surface area of the star. Now, apparent brightness of the star is equal to B naught is equal to L by A naught. What is L naught? L naught can be substituted by A naught, area is equal to 4 pi D naught square. So L naught is equal to B naught 4 pi D naught square. Or L is equal to 4 pi area into density 4 pi R square sigma into T to the power of 4. How much of energy by using the Stefan's force formula? So the T calculated T to the power of 4. Now to L is equal to 4 pi R square sigma T to the power of 4. Now first problem, star Alpha Tauri surface temperature is 3700 Kelvin. As a radius 3.2 to 10 raised to 10 meter, calculate its luminosity. First, to read the problem properly, it's the star Alpha Tauri surface temperature. Write down the surface temperature 3700 Kelvin. T is given. And radius is given. R is equal to 3.22 into 10 raised to 10 meter. Unit is also very important. Now using the formula, find out the luminosity. L is what? By using the equation, L is equal to 4 pi R square sigma T to the power of 4. So sigma is given, Stefan constant, 5.67 into 10 raised to minus 8. So substitute 4 pi R square 3.22 into 10 raised to 10 R square sigma T to the power of 4 and simplify. We get the equation L is equal to 1.443 into 10 raised to 29. Again, same problem, similar problem below. The star Alpha Tauri surface temperature is 4000 Kelvin. As radius is 3.22 into 10 raised to 10, calculate its luminosity. Our luminosity will be given. Now to calculate the radius and temperature of the star can be calculated. Second problem. So, second problem, the apparent brightness of the sun is 1400 Weber per meter square and the sun is at a distance 1.55 into 10 raised to 11 meter from the earth. Calculate the luminosity. Now, apparent brightness will be given. What is an apparent brightness? Apparent brightness means the apparent brightness of the sun. Apparent brightness of the sun by luminosity by surface area. And sun is distance D is given. First, we read clearly the apparent brightness of the sun is 1400. Apparent brightness B naught will be given that. Now apparent brightness of the sun 1400 B naught is given and the sun at a distance D is given 1.55 into 10 raised to minus 1.55 into 10 raised to 11 meter from the earth. Calculate the luminosity. Now using the brightness B naught is equal to L by area into D naught area 4 pi D naught square. So what is L is equal to 4 cross multiplication 4 pi D naught square into B naught. So 4 pi into D square. D square is 1.55 into 10 raised to 11 whole square into B naught is equal to 1400. Substitute and simplify. We get the values. L is equal to 3.95 into 10 raised to 11 watts. Okay. The apparent brightness of the sun is 1400. Similar problem. The apparent brightness of the sun is 1200 Weber per meter square, and the sun is the distance 1.55 into 10 to the 11 meter from the earth. Calculate its luminosity. Our luminosity will be given and D naught will be given, so B naught can be calculated. So this is the problem solving skill, to develop the problem solving skill. Next problem is the apparent magnitude of the star Sirius is 1 minus 1.44. Another dimmer star Regulus 1.36. Calculate the relative brightness of the star. Relative brightness of the star. Now to calculate the relative brightness of the star, the equation is m2 minus m1 is equal to 2.55 log b1 by b2. This equation gets substituted. The apparent magnitude of the star Sirius 1.44 will be given. So m1 is given 1.44, and another star m2 is given 1.36. Calculate the relative brightness. So b1 and b2 can be calculated, or b1 can be calculated. So using the relation m2 minus m1 is equal to 2.5 log b1 by b2. So m2 is given 1.36, m1 is given minus 1.44 equals 2.5 log of b1 by b2. Now to calculate the brightness of the star A, its star means series. So 1.36 plus 1.44, 2.5 log b1 by b2. So b1 is equal to 14.1906 into b2. Now to calculate the q1. If the similar problem, the apparent magnitude of the star series or the apparent magnitude of the star series A is 1.44, another dimmer star Regulus B is 1.36. Calculate the relative brightness of the star B. The same problem. Now to B1 is substitute and B2 can be calculated. So this is using the relation to solve the problem. So first, to solve the problem, carefully understand what is the formula will be substituted and which unit can be substituted and which of the relevant formula can be substituted, and simplify the equations. Now to the class, we are learned about some problems. We solve these problems in similarly using the textbooks. By using the textbooks, Dr. N. Sundarajan, College Physics, Volume 3, and Dr. Ramakrishna, Dr. Malleshappa, Dr. Prem Kumar HP, Fundamental of Physics, and Semester Sahu. By using this textbook to solve those problems, and if any doubts, I clarify it in the next class. Thank you.